So a rocket is launched from a tower. The height of the rocket, y in feet, is related to the time after the launch, x seconds, by the given equation. Use this equation to find the time that the rocket will hit the ground to the nearest hundredth of a second. So which formula should I use? Should I use the axis of symmetry formula or the quadratic formula? Put it in the chat.
Problem's gone.
What's that?
The problem is gone from the screen.
Oh, sorry. So we're talking about, will it hit the ground? When will it hit the ground? Is that a quadratic formula or a axis of symmetry problem? What do you guys think? Can you see the graphing calculator, or did I hit the wrong thing?
No, it's only the problem.
Share screen.
Yeah, I see it now.
So if I look back, right, if I'm looking for when it will hit the ground, that's going to be my quadratic formula. So see how I can use my reference sheet to help me to make some decisions about this type of problem. So now I need to use my quadratic formula. So I'm going to use my TI-84 graphing calculator software that Ms. Lobo encouraged me to download today, right? You may have graphing calculator app, something similar, right? Calculate 84, whatever, right? You can use Desmos, but we're trying to get you in the habit of using this calculator. So now I need to do a few things. I need to identify my A, my B, and my C for this problem. So A is equal to -16, just the number, the coefficient out front. B is equal to 247, and C is equal to 141. And now I'm going to use my TI-84 graphing calculator to help me calculate this problem. I cannot, it's not as user-friendly to get the fraction icon. So if you're using your TI-84 software right now, you can follow along closely and ask questions in the chat if they come up. So to get a fraction, I need to hit alpha and then y equals. And that's going to give me this fraction button, n over d, or numerator over denominator. Now I'm going to plug in my a, b, and c into my quadratic formula. So I have -b, and I always use parentheses, and I have to use either plus or minus. I can't use both at the same time. So I'm going to hit plus the square root. I have to hit second square root. -247 plus the square root of b squared, so 247 squared, minus 4 times a, which is -16, times c, which is 141, all over 2 times -16. Now you'll notice I have to use this next to the enter sign. I have to use this negative sign in parentheses if the number is negative. If I'm subtracting, like I'm subtracting -4, then I use a subtraction sign. So I'm going to hit enter, and I get a negative number. Can I have negative time Can I have negative 0.55 seconds? Is that a thing? No, it's not a thing. We can't go back in time, right? That's silly. So remember I said you have to do plus or minus, you can't do both. So since I got an answer that's invalid, it's inappropriate, I'm going to say, okay, well then I have to do the negative of that. So I'm going to hit the up cursor until I highlight this whole thing because I'm lazy. I don't want to redo this whole problem. And I'm going to hit enter. And now I can edit my data. And I'm going to just have my cursor over the plus sign and make it a minus sign. And now I can hit enter again. So now, what time will the rocket hit the ground? To the nearest 100th of a second. So remember, the 100th place is 2 decimals, but I have to look to my 3rd decimal place to decide if I'm going to round up or round or keep what I have. So is this 15.98 or 15.99 seconds? Which one would I round to?
Got 115.99.
15.99. So notice we used the vocabulary shared in the previous slides to help us answer this question. I'm going to stop the recording. You guys can head out and I will